As we have a lot, so 2 years ago we had this meeting, so we had a lot of people who are already working with Omero. This time we again have a lot of people who do not have Omero already installed and running. And therefore I thought it might be interesting again to show how our Omero is set up and how our IT infrastructure looks like, yes? So normally the others, like from Cologne and so on, they know it quite well. But I thought maybe this is interesting for others. So I will start with this. Yes, so we can look. Okay, so we are running the imaging network, so the imaging facility basically in Münster. It's a little bit different concept to a classical facility, as we are trying to integrate at least to the central booking schedule and some central services, all of the microscopes at the university. So there are some who don't want to be part of it. That's fine. We have anyway more than 70 systems available now from 80 different groups. But we also have our own microscopes where we do classical facility work, where we have, bring them in good shape, doing the introductions and all of this. So we are using Omero for data storage. We also have other data storage, but for imaging data, it's mainly Omero. There we have also roughly 80 groups, but they are different from these ones. So there are a lot of cooperation groups, for sharing material and so on. So these are not the same groups like here. Also for courses, for trainings, we are using Omero directly. Users, active users, we have to look it up again. There are more than 1,000 students registered in Omero, but this is also a lot from the pandemic where we did online courses. And all of the courses, I'm not sure how many of them are really active. That more and more now, 250, 300, I'm not sure. Yeah, this we have to look up. And we have also a Hive, so a Windows server for our analysis software. We have the Jupyter Hub and VMs in the university cloud, basically. This is not working here. So this is how our university cloud basically looks like. So Omero is installed centrally on a virtual machine, basically in this cloud. The cloud is managed via OpenStack. So we have an OpenStack cloud in the university, and we have access to it so that we can create our own virtual machines. And all of this is connected with a central data storage, where we just ask, hey, we need more data storage, and then we can expand the data storage for Omero, but also the data storage of a lot of groups is within this cloud, yes? So here we have the Hive, so our analysis server, Windows-based analysis server for remote access is directly connected. So this is in the server room of the university, and also the Jupyter Hub or the high performance cluster is directly connected to the data and to Omero. What is kind of special is that we have quite good relations to our library. And so we are able, with a contract of them, that we can give DOIs directly to the data in our Omero. So our Omero is open to the public. So you can reach it, you can find it from the outside. So the public groups. And we can make data available for publications to reviewers or directly out of Omero, so raw data. And we are taking care then for backup and so on. But this is possible because the university and the library, they provide the data safe for public data, where we store the data for 10 years, curate them and all of the stuff. But this is also saved within the university cloud. So we have the data anywhere already at this point. Yeah? For publications, we still advise people to use the Bioimage Archive, IDR, or other repos, because no one will find our data if you're looking for data in our Omero. If you see the paper, you can click on it, you have it. But the other way around, if you're looking for data, the big repos is a point people normally go for. Yes, that's why we still upload to IDR or BIA, or we advise this, but this is a possibility, quite practice in a reviewer process, so we can make with the DOI the data directly accessible. Okay. Yeah. So we have seen this. Yes.
But there are also, I guess there should also be an arrow from the microscope to the Hive, right? Or is the Hive only talking to the cloud?
No, this is possible. Also from the user, so you can access a Hive. So you can access a Hive and yeah, depending, the Hive has an IP, so we can via VPN we can basically access the whole cloud. So if you're in the university network, you can access the whole cloud. So this is basically to everything. Yes.
One more technical question. The Hive is a Windows machine, right?
Yes.
And the 50 gigabit connection, is this going to the storage underneath Omero, or is it going through Omero to access the data when you do processing through the Hive?
No, it's to the storage basically.
To the storage. So
yes,
you're asking Omero, where is my data, and then you're going to the file server.
I guess if you're using, I'm not sure if you're using software which is where Omero is integrated, and you then browse through Omero and saying there's my data. If you then can, if it then goes directly to the data or via Omero to the data, I'm not sure about it. It goes by Omero, okay. So there is a possibility to access this directly. We haven't done it yet because we don't want to touch the files in the Omero dir. So at the moment we upload the data via the inside client. Yes. So still, so this, but I will speak about this later.
So it's adding to the publication URL, but who creates the URI? It's not a part of the automated process.
No. This is on request, and then we are doing it. Jens is taking care of it. We have, help me with the name. We have to give the metadata for the publication data site, for data site, and we also have a small internal contract with the library, what our tasks are and what we have to do and have to take care of. Yeah, like landing pages are special rules for this. And if the data is moving, we have to guarantee that the link is pointing to the data anyway. Yeah, so this is, yeah, it's doneable. It's not that complicated. Okay. So this is basically the infrastructure, and if you have Fiji, cell profiler, QPath, everything nicely connected to your data, or with a Hive, with a Windows machine, or VMs, you can easily pull data from Omero, analyze it, and upload the processed images directly and also the regions of interest. For example, we have done this for cell profiler. So Sarah wrote, I guess together with Jens, help a bit, a cell profiler Jupyter notebook, where you're just creating in cell profiler in the GUI basically your pipeline. You're loading this pipeline, saying which data from Omero you want, and then you're doing batch analysis directly on the data of Omero. If you enter then the data in Omero, you have the link back to your results, to your ROIs, and to result images. For example, with cell pose, whatever you're using in your cell profiler analysis. And we thought that this might be something that users want to use Omero more, but this is not the case. You tell them that this is possible, they still like it to have their data in a folder, do it like this. So this is not something we are doing quite often. We can do it, but it's not asked by users that frequently. Yeah. Maybe because we have a lot of single images analysis, stuff like this, and not so much high content analysis. Yeah.
Thomas, sorry, all the data that are displayed in Omero, they are in the cloud, right? Or can they also be on the Hive? Or
no, they are in the cloud.
Okay, so on the Hive you don't use Omero.
No, you can access the most of the data if you're using Fiji, for example. We're using the Fiji plugin just to load the data from Omero. And this is much faster than from your office. Even if work groups have their own data storage, their own NAS, yeah. They're saying, hey, I have it here, I'm sitting in my office. And I say, yeah, but if you have a light sheet data set, you're much slower than remotely accessing to the Hive and then loading the data, because this is quite fast. Yeah. But what we would like to do, as the data and groups are using the cloud now anyway. So we were 5 years ahead. So now more and more groups jumping on the cloud, because the data storage on the cloud is for free. It's not directly backupped. It's very safe. It's 8+3 erasure coding, self-healing, and all of this stuff. But now more and more groups have their own network share within the cloud. So if they're saving their data, the data is anyway in the cloud. Yes, and we thought, okay, then we can make an in-place import or kind of an automatic import to Omero. So we do not have to duplicate the data from the cloud to our Omero data tier if we are using the inside client. So this is kind of a duplication. But we need a rule how people save their data, and yeah, that they are not deleting the data after the in-place import. And when we discuss this, yeah, we recognize then we need people also to annotate their data. We need some information for this, for Omero. And this was sentence for me from one PowerPoint. So from 2023 on an IDR meeting, I3D Bio meeting, that I guess that, yeah, convincing users to use key value pairs or metadata to their data is maybe the most, yeah, difficult task we have to do. So we do not have the manpower at the moment to really train the people that much that they really understand why it's important. So in my opinion, the PhD students, yes, he knows all of the metadata. They have it in their head. They do not get directly the benefit of annotating their data. This is something for later, for the publication process, and so on. And yeah, the idea was to give them more or less useful tools they want to use and that makes their life easier. So if you can say, hey, if you're doing this, you have less work and you have some benefits, then they might use it. So this is what we want to do here with the automatic import and with tools like this, that we can do it very nicely in this. But this was all already done in 23, but didn't work out that people or PhD students really annotate their data and using it. Omero is coming more and more and more. So if they learn it, they want to use it, they first is in contact, that's not the point. But at the moment, we have the problem with that people are annotating their data quite well. So therefore, we were looking for some strategies. First, how to train people to save their data in a nice way. Because if you're looking to the different work groups, they have completely different ways to organize their data and to save it. And if we want to use the in-place import, we need some rules for it, yes. However, we are not in Leiden. We do not have our university in our back who says, okay, that's the plan now for everyone who's doing microscopy imaging. Save it like this. We can do it on our own microscopes, but not for the whole university. Yes, so this is that we do not have the power for it. And so we thought then it might be good, or I thought that we train basically more the local data management, because they are producing images directly at the microscope, and we have to train them how to save the local files in a good way. Yeah, I don't know if you know this, so we get file names which are that long with question marks and whatever inside, and if you then want to do something with it in an automatic way, yeah, everything is crashing. Like a space is already not good if you're running your scripts and things like this. So why you should organize your data. Maybe I can skip this. So the question is if you can always tell which file contains which information you're looking for. Do you know a future version of yourself or your PI in 5 years, if you are already at another university, knows where it can find your data, understand your data, and are you always sure which version of a file? This is maybe not so much for microscopy, there you have always the raw image, but is a last recent, or for analysis, which was the last file I used. And therefore, we come up with some recommendations, and if you look for this in the internet, you find quite fast always the same recommendations. And the first of this is basically that you should add a README to your files, to your creation of your files, that you know what is it about. And this is also from the ESA standard, that you have a README, human readable, computer readable, attached to your file, just with a short description what you're doing. The next one is that you have templates for folder structures or a defined folder structure, especially if you're working in teams, that everyone is doing the same, yeah? That you have 3 or 4 levels, not too deep going, and then 7 folders in parallel. This is what you can see quite directly. And maybe also name the folders with 01, 02, so that you directly know where to go. Yeah, using temp files, ESA standard is basically the same like this folder levels. You have the investigation is the first level, study is the second level, so you can go on parallel, and then you have a third layer, and not too deep going into folder structures. For file names, yeah. Here we have an example. So this is what we did for if we get a project for analysis. We thought we need also a common name, so they get a number and an internal prefix here, so that every student coming with a project for analysis gets kind of this numbers. So we're using at the moment or now eLab for the World to creating this counter. Yeah, we're also creating an eLab entry experiment for image analysis tasks. This is the same number then, like on our folders. And then we have always creating the same folder structures, that if Sarah is on holidays, I can find the data from someone else, and I know where the macros are saved, they are using and working on. Yeah, exactly. So the next is basically file names recommendations, what you should avoid. I guess this is also for the most of people. I've seen some smiles here when I was telling this a second ago. That you should avoid spaces. Yeah, please use underscores or hyphens instead. If you have more versions or a lot of different images, you can use counters with 001, for example. A date in a common way that the computer can read it. Yeah, even if it's not that native for Germans to write it like this. But there are benefits of it if you're doing it like this. Yeah. Do not use things like final 2. If you're writing a draft, this is the final version, this is final version number 1, this is final version number 3, no one knows what it is. Yeah. Use a date or just an upcounting, and then you know where you are. Yes. So you can then use something, if you have notes or something, you can use it like this. Version 0.2, yeah, 0.201 for minor revisions, for major revisions, whatever. If you have always the same things like lab meetings, you can also agree on your group with aberrations. LM is always the same. If you see a file, you directly know what it is. Yeah. But this, you need to decide in your group. Depends. Okay. So after I learned this, make this short, README templates, file naming, I thought, okay, is there a software which can help me to stick to this? And if you wrote then, you get a forum and they say, okay, if you want to create folder structures, write yourself a batch file. Yeah, so there's no software or basically no directly small software available to where you have templates to creating folder structures, taking care of file names. So there are renamers and stuff like this, but there was nothing existing. However, there was this tool from Thomas Harschi. I guess he presented it 2 years ago on this meeting, which is basically doing this. Yes, and I started with this and find it quite practical. So it creates folder structures, predefined ones, but only one. It creates a README template. Who is the author? You can give your ORCID ID, whatever, the experiment details to it. And you can create experiment templates with metadata and YAML files to it. Yeah? So this is then all of the project. So it scans a directory. You can create new projects and upload data to it. And then it locally creates YAML files and the structures. So you can load this. This is one of these YAML files templates for a microscope with device, specimen holder, whatever you need. Basically, you have the templates directly to your metadata. So this worked quite nicely, but it was not that flexible. And that's why I created another program. And okay, so here's coming metadata again. Again, I guess I can skip this. So why is metadata important? I have to hurry up a bit. So what we tried before to get users to use metadata, to get metadata to their files, is basically CSV-based metadata annotation. So we had templates with macros in Excel. They could upload it, but I guess there we had too much steps. They didn't use this CSV files for something else. So users are not using it, even if we explained it on their own a lot. The other thing was basically it's called tables. This is a program which allows you quite quickly to tag your folders and files with a small program where you just type in basically your value, temperature, 37 degree, whatever, and you can tag your files quite quickly. However, there's a problem is that due to licenses, so it's proprietary software, we only have it at the computers, so it's microscopes. You need the database to set this up, and users have then to go to Omero and run a script to get the metadata out of the SQL database, basically. However, it was quite fast, and I used it 2 years, 3 years now on my computer at home for all my files. So it's quite good, but nothing all of the users are doing because we do not have the license that they can do it also on their computer. Otherwise, we need 1,000 licenses because you need it for every computer you're using. So this is basically a problem. So therefore, I tested something else. So, or we installed all or some of the other tools which are available now, which are upcoming. This is Adamant. JSON files, templates, basically. You can send the data directly to the eLab for the World, I guess, at the moment. This is Leo linking your electronic lab notebook with Omero, so you can load the metadata and the entries from eLab for the World, OpenBIS, I don't know exactly, and Omero, so you can display both entries at the same time. However, we had problems to set this up here. So it's server-based. You need a person who is setting this up for you. And turned out that we are struggling and that this is highly depending on your IT, on your infrastructure, and if you have persons who are doing this. I hope this will be better. We are in contact with them, and then these might be cool tools. But at the moment, we had problems with it. And therefore, I asked one of my new colleagues, Cloud AI, to write me a small program to overcome the small limitations we had with this RDM desktop tool. And this I quickly want to show you, to present you. So it's not working here. So, okay. So this is basically how it looks like. If you started, you're logging in, you can select a username, a password. So it has group management and user management for the reasons if you're using it at the microscope. You can install it. It's a local program. You can install it on every computer. You have it for Windows at the Exe we have to check if it's really working on Mac, and so at least we have a DMG file and Linux. This we still have to test. We haven't used it that much in production. Yeah, so it's quite new. I have the code on GitHub, but it's really fresh. So what you see on the left side is we have different categories. So you can sort your templates, and here you have templates for metadata and folder structures. So if I'm going to a main project, so this is a little bit like the ESA standard, so investigation, study, essay, and something else, but you can rename this. So if you're going to the options, you can easily, general options, you can easily rename it as you need it. Yeah, you can also flies, zebrafish, whatever, how you want to do it. It's just that you have some more ways to order your templates here. Here we have our templates for image analysis. So if I'm using this, we have here the folder structures. So we're getting folders and subfolders directly created. And within the template, if you choose one, you can browse basically your paths where you want to save something. And the project name, this will be the final folder then. So on this one, I just have the structure, now experimental metadata. This is then in the ELAB. So we can go to, don't know, one of the templates, LSM 980, RDM4mic metadata. And you see that here's the path where you want to save it and the project name. So the folder we have is already saved within the template. So you just have to change this one. And also the metadata for the drop-down menus, this is already saved. If you want to change it, you can just save templates and paths, and now you have saved the different metadata to it. Yeah, this is that you just change what you just have to take action on what have changed, yes? And if you have always two different versions, you can create two templates out of it. You can duplicate the template, and then you have different ones of it. So this is how to create it. And if you want, you can go to the options, and you can enable, at the moment, ELAB for the world and Omero. It saves for every user the login credentials. And then you can say, okay, I would like to send it to ELAB for the world. I have a template in ELAB. So add the metadata to the template number 5. This you have to know. And connect to Omero. So we are connected. So all of this detail is saved. And then I can collect the group. Just creating the project with all of the metadata here. Now it's working. And we can open our data in Omero and in ELAB for the world. And now we have here our new project, RDM4mic, with all of the metadata as extra fields. And we directly have the Omero link in ELAB for the world and in Omero. If I'm logging in, we also directly have our key value pairs added to Omero with the link to ELAB for the world. So this is directly linked, both is there. And we are using it, Jens wrote a script that we also have basically now the local folder where we have a JSON file and HTML README where we have also the links to the dataset ID. So if this is next to the data, students do this at the microscope, creating the folder, saving their data into the folder. This is anyway at the cloud, and we are automatically uploading this data, the files at the microscope to the dataset we have in the ID to Omero. So that this is basically, they just have to use this tool. They do not have to import the data anymore to Omero. We have it saved. We know to which user has used it. We have the login data for Omero, so we know which user to which dataset ID, and we have linked ELAB for the world and Omero to it. So this is my last idea to convince people at the moment to make it easy to them to add their data. Okay, I guess I'm horrible over the time. I'm sorry.